So you are able to see my screen? Just anyone give me thumbs up, please. If you are able to see my screen, just give me one thumbs up. Okay, I have so much thumbs up. Okay. Okay, so the last time we discussed the project, I think so. You should have already started working with a project. I hope that you don't have a problem with communication with each other. If any group suffer from any communication issue, drop me an email. I will send email for the whole group to put everything on the track. Even though I prefer not to jump in this, but if you feel that I need to jump, I will do it. I will be happy to help to support that the team will be in a healthy, cooperative situation. So if you suffer from any communication issue, let me know. As I said, I prefer not to jump in this, but if you see that you need me to jump in this, I will do it. And we talked also last time about relational algebra. We said that before we start writing the DML query, where in this we are going to write later the query that we use it to insert, select, or update or delete data. Since we are done with the structure of the database, we said we have to learn relational algebra. Relational algebra it's give us more the fundamentals that we needed to build later a relational SQL query. So the last time we talked about what is a relational algebra, and we talk about today we should finish the relational algebra. So starting from the next lecture, we will start writing SQL, a query based on what we have already learned in the relational algebra. We talked about the main operation like set operation, projection, selection, and we talked about joining, how we can do it using Cartesian product, natural join, or theta join. And then we talked about naming and renaming, and we start thinking about that. To build a query, we need to write an expression where more than one operator is being used with different operand, which is in our case, the operand is the relations. Any questions concerning the last lecture before I start the new one? If anyone has any question, go ahead and ask me. Okay, I don't see any hand here. So today we will, as I said, we have to finish what is a relational algebra. And we talked we need to talk about what is a bag, because the whole relations that we considered the last time, we deal with them as if they are sets. In algebra, when we said it is a set of a value for an entity, then it is no duplication is allowed. But if we said is a bag, there is a duplication is allowed. You see it? And we will revise the different operations that we have already discussed the last time. However, we will revise them based on what we name it bags. And then we'll talk more on extended operators or operation. They are more advanced comparing to what we have already discussed the last time. And like always, we will end up with a lab exercise. So bags, what are they? So set of tuples, when we deal with an entity like a table or an entity, we name it entity or name it table. When we deal it as a set of tuples, then, as I said, no duplications allowed. However, if we deal with a bag or multi-set, then duplications are allowed. So it is a bag because duplication is allowed. We can say it as a bag or a set. Both are correct here because there is no duplication, so it can be set. And a bag, it is a more generic comparing to the set. So a bag duplication is allowed whenever there is duplication. There is no duplication, still it is a bag. So as I said, the main difference, just duplication is allowed. So what will this affect? Now, if you remember, for example, if we make a projection here, if you are going to deal with the table as a bag, then if I said project AB, if you remember from the last time, projection has this sign, AB. Let's say it is X, for example, the name of the table. So projection here in this case, if it is a bag, then duplication will stay here as it is. If the projection it is into a set, then there is no duplication, as you can see here. So 1, 2 will not be duplicated. We will have only one instance of 1, 2, since we have a set. This is what we have already considered the last time. Today, we will consider the table as a bag. Okay, so assume that a query is asking for an average, which is in this case set or a bag. So I think so we need to have a bag, because if we are going to consider it as a set, so we will lose some data, because we are going to calculate the average. So even though there are some items or some tuples is being duplicated, we should consider to have the final average value in this case. So why we need to have a bags, and what is related to SQL later when you are going to write SQL? So SQL is the most important query language that we have already used so far as a DDL language to create the database structure. However, it is actually a bag language. Papa say again, so suppose you are going to create any aggregation function. We will see aggregation function. Aggregation function, then you are going to apply a mathematical operation like estimating the set of the list of the summation, minimum, maximum of a special attribute. When you write your SQL query, then you have to consider each item, as I said. In this case, SQL will deal with a table as a bag. So now there is a question, since we are going to deal with a bag, so if I give you an operation, an example in the exam or whenever, and you don't know if it is going to use it as a bag or a set, I will say, no, use it as a bag. So the default is a bag, not a set. The last time we need to consider set, because set is the fundamental classical relational algebra, how it works. So a relational algebra, the classical, the fundamental, the naive version is consider everything as a set. However, to be more practically, especially when we talk about the set as a relation, as a table, we should consider it as a bag. Again, we should consider that we will do different operation, which means that, okay, but you said in database, we have a primary key and there is no duplication. Yes, but normally we will not make the operation only directly in the table in the database, like we are going to join two tables. The output now, there is a duplication. So in this case, SQL deal with everything by default as a bag, not as a set. This is why it will be good to revise the operation or the operator that we have already discussed the last time by considering now as a bag, not as a set. Just I need to let me take attendance. So I can collect it from here. people, yeah, downloaded in this list. Okay, so what about union, intersection, and difference? Before I start with union, intersection, and difference, we said the last time that to use union, intersection, and difference, there is a condition. Anyone remember what is this condition? Anyone? Anyone remember what is the condition to use union, intersection, and difference? We can't apply this without having this condition. Who will give me the correct answer within 1 minute? I will give him or her +5 in the assignment. So Ken, you will be the first one to answer. I will wait more 60 seconds before I get your answer.
They have to have a common attribute and values in that attribute.
Yeah, this is Ken. Is it correct?
Yes.
So I have Ken and Zach also put something in the chat. So yes, they should have the same schema, which means the same number of attributes. Ken and Zach, can you send me an email just to remember you when I will send an email? You said I have a bonus 5 point in the assignment. Assignment 2.
Sure, thank you.
Yeah, and Zach, please, can you send an email also? Just to remember you later when I will publish the grade for assignment 2. Yes, thank you so much, Zach and Ken. As you said, that yes, we need to put to be the same schema to apply them. The same case when we deal with them as a bag. They should be the same schema. So the union on bags. So we have here two relations with the same schema, A and A, B, A, B, and then we are going to apply union. So union means that we are going to get what we have in both, not in common. So we get everything that we have in both. So we have here 1, 2, 1, 2, 3, 4. Here we have 1, 2, 3, 2, 3, 4. So in this case, we will have 3 because duplication is allowed. We will have 3 times 1, 2, and we will have 2 times 3, 4, and 1 times 3, 2. Duplication is not removed because now we are dealing with the union for bags. Brainy. Brainy is asking the first question for today. So if T tuples appear n times in bag R and m times in bag S, so you have a T tuple that appear n times in R and m times in S. How many times it appear in R union S? So again, it appear n times in R and appear m times in S. So how much it will appear in R union S based on what we have already seen? Josh is the first person, so, and then we will go with Harmondine. So go ahead, Josh, and we have something in the chat. Yeah.
Wouldn't it just be m plus n?
N plus m. Harmondine, do you have the same answer or another answer?
Same.
Okay, let's see in the chat. So in the chat we have, yeah. So people in the chat say yes, n and m. Just Simran maybe the difference n times m. So yeah, it will be n plus m, Simran. So based on this example, so here if you have, let's take 1, 2 as an example. We have 1, 2 here 2 times, and we have here 1, 2, 1 times. So n is 2, m is 1. So it will appear 3 times here, which is n plus m. Thank you, Josh, and the others about the answer. So now what about intersection? Here intersection, which we will take only what we have in both. But now there is a big question. that we have a common attribute, however, we have different instances. Like 1, 2 here. 1, 2 appear. Harmandeep, do you have an answer, a question, or are you still raising your hand?
Answer for this question.
Okay.
Yeah.
Go ahead.
Okay, so 2 times 1, 2.
2 times 1, 2 you will have. What more, Harmandeep?
That's it.
That's all.
Yeah.
Yes. 2 times 1, 2, because we have here 2 times. Thank you so much, Harmandeep. We have 2 times 1, 2, and here we have 3 times 1, 2. So we have 2 instances in common that we consider in the final here. I think so now, based on this, Brainy is going to ask us another question. Is if we have tuples appear n times in bag R and m times in bag S, how many times it appear in R and S? So it appear m times in bag R and m times in R and S. So Ken is the first to answer. We will. Ken, I saw your hand, then you lowered down.
Yes.
wait.
No, it's okay.
Don't give me an answer now. Just let's wait.
Oh, okay.
So yeah, you can give it your answer now if you want to share an answer before we go to Harmandeep.
I think it's the lowest between N and M.
So you mean the minimum?
Yes, mean between N and M.
Yeah, Harmandeep?
Same answer.
Same answer.
Yeah.
Yes, it will be the minimum between N and M. That's correct. Thank you so much. Yeah, it will be the minimum between N and M in this case. The last operation was difference. When we say R minus S, as far as we have already discussed the last time, yeah, I'll give you a break later, Ivan, and you can get your coffee. So the difference between bags, in this case, similar to what we have already discussed the last time when we talk about difference in sets. So what we have in the first and we don't have in the second. So in this case, here we have 1, 2, 3 times, and we have 3, 4, 1 time. Here we have 1, 2, 1 time, and 3, 4, 2 times, and 5, 6. So if we have 1, 2, 3 times in the first, and 1 times in the second, so we have it 2 times more in the R. So again, R minus S, what we have in R and we don't have in S. 3, 4, we have it in R and we have it in S in the same number of instances. So we will not include it in the final result. And 5, 6, we have it in S, but not in R. So it is not part from R minus S. It can be part from S minus R. So in the S minus R, we have 5, 6, that we have it only here, and we don't have it here. And the 3, 4, we have it 2 times here, and we have it 1 times here. So if we said S minus 4, so 3, 4 will be 1 times as apart from S minus 4 in this case. So selection and projection, let's return it back, selection and projection, how it will be in the back. I think so we have already, seen the projection at the beginning when we talk about what is a bag. So selection, as far as you know about selection, when we have a condition, based on this condition, we are going to make a selection for a special tuple that satisfies this condition. Again, duplication is allowed. So C greater than 6. We have here C greater than 6. We have here C greater than 6. So duplication is allowed. So we will have a duplication here. By A, then I will take the A as it is, even though there will be a duplication, will be in the final output as we can see here. Brain is asking. I think so. You need somehow to solve it by using a pen and a paper, or if you are extremely smart, you can solve it without anything here. So the question is, suppose you have this operation. It is an expression, not an operation. We have this is as a first sub-expression, and then we have a difference with this expression. So the output of this, it will be a relation, and then we will have another output, and then we will make a difference. So what will be the final output considering this table? Take 1 minute and don't share any solution now, even though on the chat. After this, you can share in the chat when I said you are able to share, or you can raise your hand to discuss it verbally. So yeah, I will wait 1 minute for this. Again, the question is, what will be the final result considering this relational algebra in this case? Okay, who has a solution for us? Anyone can give us a solution for this? Go ahead, Ken. And I think so we have somebody else also in the chat. So Ken, yeah.
I'm not sure about this, but I think it's the same table without the ones that say spring 2013.
No, it should be as no, this is not the correct one. So it will be as
Okay.
Zach said, Sanj 405. This is correct, Zach. Thank you. And Ellen also said, Zach. So both are correct. Yes. So I think so it will Sanj 405. Let's discuss it. So let's go in the first expression first. So this expression means that select, let's take this only first. Select the tuples that has semester spring and year 2012. So let's go to, this is spring 2012. This is the first one. I will put dash for the first one. And then we will have, let's go from the first. This is spring 2000, this is. And let's go more, this is. If I did a mistake, just correct it for me. So I think so for the first one, again, we have spring 2000. This is, we have already selected. Spring 2000, spring 2012. So we have 3 from the first as a selection. And when we set the projection, then we will take only the value of the course ID. So in this case, we will have this, because we have a projection. So we have this. So the output of the first one, I can write it here like this. It will be a relation with one attribute because we make a projection here. So it will be a course ID. And we have 3 values. CSCI 300. We have Sanj 410 that I mentioned here. And we will have Sanj 405. This will be the output for the first. So let me make it better. This is for the first expression. let's go to the second before we will go to the difference between them. The second, I'm not sure if I can choose. Let me check this if I can use another pen light, highlight, no. Green color. Ah, yeah, that's good. There is an option I can choose another color. So now let's go to this one. So semester spring and year 2013. So I think so we have this. And we have this. And spring 2013. We have this. And we have this. And we have this. And we have this. Is it correct? So in the second, we will have this. And we will have, sorry. Oops. We will have this. And we will have this.
I think you're just missing one there.
Yeah, this is, I just have to change the color to be
You're missing
consistent.
the Senge 410 below the Senge 415 in blue.
Yeah, just give me 1 second. So yes, I make, yes, you're correct. So I have, let me change the color again. Thank you, Josh. Yeah, we have here now, this is also. Is it correct? Did I miss anything more? So let's go now. So if we make this minus the second one. The second one we have Senge, I will not write it again. So we have Senge 400, 300, and so if we go CCI 300, we have embossed CCI 300. So we will not use it anymore. 410, we have here 410 and we have here 410, so it is embossed. Senge 405, we don't have Senge 405 in the second because the difference what we have in the first and we don't have in the second. So the answer in this case, it will be Senge 405 as we mentioned here. Any question about this? Let me change the color again. So the aim from this question is to know what is a selection. And after we make a selection, we make a projection, which means that we will get an attribute, we get an entity or a relation with only one attribute. And the second one also gives us a relation with only one attribute. Since both have the same schema, only have a course ID, in this case, we can make a difference. What we have in the first and we don't have in the second, which is, it will be Senge 405 in this case. Any question? Sure, no questions. Okay, let's make a projection, a product and join now, what we have already discussed. It will be a good that we are revising them, but using bag, as I said. So product and joins on bags. If you remember, product means that we are going to take what we have in the first with everything what we have in the second. The same here. So we'll take 1, 2 with 2, 3, 1, 2 with 4, 5, 1, 2 with 4, 5. Again, duplication is allowed. And then we'll take 1, 2 with 2, 3, 1, 2 with 4, 5, 1, 2 with 4, 5. Again, duplication is allowed also here. Same product we know, but with duplication is allowed. Natural join. Natural join, we can't apply natural join without having a common attribute. And then we will make a joining based on the common value and the common attribute or equal value. So we have here 2. Then we are going to join it where we have a 2 here. So 1, 2, 2, 3. And then we will 2 also we join it with again with this one. 1, 2, 3. So this will be the final output, same as we know, but with duplication is allowed. Set a join. Set a join is when we have a condition to be applied, like here where B in the first less than B in the second. So if you take this B here, it should be less. So we can take it with this and we can take it with this. The same for the second in this case. So you will have 1, 2, 4, 5, 1, 2, 4, 5, 1, 2, 4, 5, 1, 2, 4, 5 in this case. Now we revise what we have in the old one. However, we revise it in a way that by applying this to a bag, as I said, by default, we consider relation as a bag and SQL consider it later when we will write the SQL code. And we don't consider it as a set in this case. Josh, go ahead.
Yeah, I just had a quick question. So when are we gonna see sets and when are we gonna see bags? Are we defining that in SQL or is it always gonna be bags?
Okay, I will tell you something. So now we are learning the fundamental relational algebra, which means that what different operations is being based on this state of the art. So the fundamental or the classical relational algebra can consider as a set or a bag when we talk about set of values. But in our case, since we will apply the relational algebra later to a database and a database management system that consider SQL like MySQL, so we consider it only as a bag later, not as a set. So the fundamental one either can consider it a set or a multi-set, which is a bag, when we talk about relational algebra. But when we talk about a relational SQL query, we will deal with the table or the relations or the tables that we are going to apply the query on it or on them. If you are going to apply it on one table or more, we are going to deal with them as a bag. So in the MySQL environment or database management system environment, we will deal with them as a bag. But from theoretical fundamental background, relational algebra can be applied to a set and a bag in this case. Does this answer your question, Josh?
Yep.
So let's talk more about extended operators, operations that more than the classical one, like the selection, projection, product, and join, and union, intersection, and difference. What's more we have here to consider as apart from, I know that we have so much operation, but you should be aware about the basics or the main one, because when you will build your query, you will not be sure how many operations you need to build this query. Because a query, it will be an answer or a request by the user. To fulfill this request, you want to build an SQL query. To build an SQL query, you need to build more than operation using more than operator. So you should be aware about the basics or most of the basics to be sure that you are going able to build the SQL query later. So duplicate elimination. There is an operation where duplicate elimination. So it is as if you are changing a bag of the set. So if you want the final result without duplication, because it by default, you will get it with duplication when we deal with a bag. So use this operation, you just give an input the relation, it will return back output without duplication. This duplicate elimination operator, we name it. Aggregation. Aggregation is when there are some mathematical operation, we are going to apply it either in a set of attribute, or we will apply it based on a group of attribute, a group of tuples, as we will see. So what aggregation function, the basic one, we have it here. It is by default, it exists. And even later when you write at an SQL query, you can use them as a function. We will have some average, minimum, maximum. We can apply it to one attribute or more. Like sum B, then you will return the summation of B, like here in this case. You will have a 10, we'll have an average, you will return the average of A. You know about the average minimum, we have the maximum, you can apply it to A, B, or another attribute. We have the count and distinct count. So count will give you how many non-null value you have in this attribute. The distinct count doesn't consider duplication. So in A, we have 1, 3, 1, 1. So we have 4 different values. It is incorrect to say 4 different values. We have 4 records under the umbrella of A, and all of them are not null. So in this case, for distinct count, we should consider no duplication. So for us, we have 2 distinct value, which is 1 and 3 in this case. Grouping, and normally aggregation function will come with a grouping. So as I said, okay, today, please, I ask you as a database administrator or a database administrator, I can say it, or a database expert working with our reporting system. I said, hey, please give me today the sales or the average sales done by the salesman for today. So if I want to take the average sales, I will get all transaction and make a summation divided by the number of transactions. However, if I ask you per salesman, so I have to apply the average function, not for the whole record, to apply it per category of record, which is a record related to a special person. And normally, most of the time, aggregation function should be applied like this, with a grouping. So we have an operator, this is the sign of it, which is make a grouping, group special record based, like here, if we said group by grocery store. So I will have this grocery store groups like this. So we will group them based on the value of the grocery store. Now, if I will apply aggregation function, this is very important. This is extremely important. You should be aware about it. If we'll apply now the grouping, if we are going to apply the aggregation function per group, in this case, see this, I said group by drink and calculate the average of the price. And the final output, because the average of the price, I will get a new column with the average, rather than grocery drink price, I will get a new column. I said name it average price. This is optional. If you don't use it, it will get this is as a name for the attribute. If you use it, you will get this is as a name. And then for the table says, now the average function will not get for the whole price. It will be applied the average per group by. Why? Because whenever you use, again, listen to this. Whenever you use group by with aggregation function, then automatically this aggregation function will be applied per group. So here this is my output will be, I will have a drink where we have a Coke Zero, Pepsi, and Mr. Juicy. And here I said, okay, this is good. Then we will have, I said, make a group by the drink and calculate the average price. The new attribute, name it average price. This is what happened. So I go to Coke Zero. How many Coke Zero I have here? 1, 2, 3. So I take this, plus this, divided by 3. Sorry. Divided by 3, I get this value. And then I said, okay, Pepsi Max, I have this, only one value, so I keep it, this is average. Mr. Juicy, I have this and this. I divide by 2, I get this value as an average price. So the average price here is being calculated per category. Which category pays in the group by that I have already defined. And whenever I set a group by drink, as if I'm making projection per drink, it will be automatically in the final result, as we see here. And then we will get the aggregation function per group, not the whole values in this case. Josh, go ahead.
I was about to ask, so when you're grouping by drink, you're not getting rid of the duplicates. Is it the act of adding the average price that gets rid of duplicates?
Yeah, we are not going to get rid of our duplicate because we are dealing with as a bag.
Yeah, exactly. That's kind of what I'm asking, because you have only one Coke Zero on your output there. Would there be all three of them with the same average price, or is it
No,
just
but
that?
how, when you said an average price, the average for a group, not for one of them. The name
Yeah.
of the group is Coke Zero, but we
Yeah.
have 3 items in these groups. So we are going to calculate the average for these 3 items. So we consider duplicate here. If you don't consider duplicate, then we will not consider the 3 values. Is it
Yeah,
correct?
that's what I mean.
Yeah.
I'm just curious because I know in the last one, when we grouped by grocery store, we didn't get rid of anything. So is it just because you said average price
Yeah,
there?
because here
Is
when
that
we
what
go
causes
by,
it?
we didn't calculate any aggregation function.
Okay. Yeah.
But we have here aggregation function. So when we have aggregation function, this will be the new attribute, and this is the main attribute. So in this case, we will show only the the aggregation function attribute per category. So
Okay, sounds good.
we will show the aggregation attribute output. This is why we see here this just the value of the aggregation function. Again, because we have aggregation function. But the point, Josh, that's very important that all of us know about this, that we didn't say for the compiler later when we will write the SQL query that this average price is this for this category. Automatically, whenever there is a group by and there is aggregation function in the same query, in this case, it will consider this as per category. So this is this is a very important point here, that we didn't tell that please calculate average price per category. We said make a group by and calculate average price. So here now the compiler automatically will not calculate the total average price. It will calculate the average price per category in this case. I think so. We will take 2 questions from Brainy, then we can go to break, that Ivan can have his own coffee. So, so question 4 is, Brainy is asking now the same table that we have it for, but now he's asking us to write an expression. Write an expression that finds the number of courses given in each building. Again, number of courses given, write an expression that find number of courses given in each building, in each or per. Whenever we hear this word in each or per, then we need to make a group by in this case. Josh, do you have a question or you want to give me an answer? If you want to give me an answer, I will take it from you the first after giving some time for the other.
Yeah, I have an answer, sorry.
Okay, perfect. No worry, no, keep it up, keep your hands up. Thank you so much. You will be the first to answer. I will give more time to the other to think about it. Just give 1 minute more to the other to think about it. So the question, as I said, the number of courses per each building or per building in this case. Josh, go ahead.
So would it be just the gamma building with the aggregate function being a count on the courses?
So you mean, can you repeat from the beginning? So what will be count?
Yeah, so we'll use the grouping operator on
We use a
building.
group per building, yeah.
Yeah.
And then we will have count.
And then we're gonna have a count on the courses. Or course
Yeah.
ID.
Course ID. Yeah, that's correct. So we will have a group by building, and then we will apply count per course ID. I can give it a name. It is an option, but it is an option, as I said. You don't have to do it, but it will be better just for presentation issue. And then in this case, we will count per building. We will have a table where we have a building here, and we will have number of courses. Here we'll have the building, what we have, A, B, C, I think so, and D and E. And then we will have number of build courses in each building, in the building group in this case. Yes, thank you so much, Josh. Oh, we have another brainy question here. Do you have something in the chat? Let me check. Yeah, thank you so much, Kelum and yeah, Navipun, you are almost correct. You are correct. Thank you. Kelum, as you can see the answer, we don't say count, count, count. We said just count per group building. In this case, it will count for A and B and C and D automatically. So now the second question that Brain is asking for the same database, write an expression that finds the buildings, listen this, in which most courses are given. Take your time for this. I will give you one more minute about this. Okay, Josh, do you want to give an answer, or is still raising your hand from the last one?
Sure, I can give an answer.
Yeah, go ahead.
Could we just apply the max function onto our previous equation that we had from before and do it on the number of courses?
Yeah, there is no group by, or there is a group by?
Oh, it's grouped by. So I'm saying we can do the max function on our equation that we got from
So
the
group
previous
by
brainy
building the
exercise.
same like before.
Yeah.
But you will add max to the count in this case.
Yeah.
Yeah, that's correct. So, and let me see in the chat if you have another. So building max building. So Kelum, yeah, max building count. So yeah, so I think so. Ivan do it correctly, and Sarsak, you are almost correct, but you should make a group by, and the maximum not for the group by, the maximum will be applied to the count. So group by, Sarsak, just to make a grouping. However, all aggregation functions should be done after grouping. So we make a grouping, and then we said maximum of the count. The same, I think so, Kelum, just, yeah, Kelum, you are almost correct, but when you use this arrow just for renaming the output, not as a relation between build grouping and this. So I just use a comma here. If I want to give a name for this maximum count course ID, I will make this and I can give it a name, whatever it is, MA count, I can say it. So when I use arrow other naming, as I did here, just to give a name for the output attributes that I will have it here, or I can keep it, in this case, the compiler will name it as it is here. So I think so I will stop here. I will give you a break. It is 9:31. Is it 10 minute? I think so 10 minute will be okay. So we return back 9:40. Ivan, go ahead and see, you have 10 minutes to get your coffee in order to be 100% concentrated. Okay, guys, see you after 10 minutes. To continue, we have a short discussion, then we go to the lab exercise. See you soon. Hi. We are back. I hope that you are back also. So just to know that some of us are back here, yeah, I need more thumbs up. I have 2 so far. I need 3 more. Yeah, good. I have enough. Thank you so much. So let's talk now more about extended projection. So far we know projection, that a projection where we are going to take an attribute as a whole. But sometimes I have to make an operation and I take the output of the operation as a part from the projection or final output projection. Example. So I can make a projection by making a difference between B and A, as we see here, and the output put it in X, and C minus B and the output put it in Y. So we can run an operation as a part from the projection itself. So in this case, the output will be like this. So 1 minus 0, 1, 1 minus 0, 1, 4 minus 3, 1. B minus C minus B, 2 minus 1, 2, 2 minus 1, 1, 5 minus 4, 1. So here, this is, we name it extended projection, where we can apply an operation during the projection part. So the normal projection, we know project A, B. But here, no, we're going to make B minus A and project the output. So this is, we name it extended projection in case you need it in your query. Sorting, I think sort is an easy one, where you make a sorting for the values, and normally we will apply sorting like projection. We will apply sorting as at the end of the final result. As I said from the beginning, we are not changing the value in the database. We are getting a copy from the values, and we are presenting the result in different way, or make combination of a copy of a data for, like when we make a joining, or making a grouping for the copy of data. So we are not changing anything in the database. We will learn later in SQL data query where we are going to update the value, but there is no update here. We're just selecting values or a copy of values in a virtual container to have the final output, and the final output maybe later, if we are building a software, we can save it in other places, or we just want to view it and present it, no saving issues, like we are building a report in this case. Go ahead, Josh.
Is there a limit to the conditions we can add? So for example, we sort according to C first, and then if there's a tie, we use B, but
Yeah,
if there's a tie there, can we
this-
use A?
This is what we are going to say to discuss it, but I was giving a general observation or remark about the overall what we are doing here in the relational algebra. That's not part from the structure. We are getting copy from the data by applying different operation. Returning back to the sorting, yes, as you said, Josh, when I said tau, I use this as this is the operation or operator. This is mean I have to make a sorting based on C, and if I have a tie, which is I have an equal value in C, then I can consider B. So let's take this here. So sorting based on C, and if I didn't say ascending or descending, then it is by default ascending. If I want to do it descending, then I have to mention it is descending. So here I said, okay, sorting per C, so the least value is here 1. The second value is 2. So, and then the third value is 3. And then here I have 2, 5. So which one I have to consider? Now I have to go to B because I have a tie. So I consider this is because B is 0. As you can see here, I considered 1, 2 is this it, and then for the 5, I will consider this is first because the B value here is 0 and the B value here is 3. So whenever we have a tie, we will consider the least value in this case. Because I said make a sorting for C and B, which is consider C first. If you have equality, we consider, or a tie, we consider B in this case. I think so sorting it is an easy operator to deal with it, just sorting the data. And normally we use sorting as a final operator if we are dealing with expression where we have a more than one operation in this case. Outer join. Outer join, so far when we work with natural join we consider only the values whenever we have a common equal value in the common attribute. But we are losing some data on one of the tables. Outer join said that sometimes we need either to keep the data from the left relation or from the right or from both. So outer join said, okay, let's take the full outer join. So if we consider it as a natural join, forget about this, this will be the output. So in the common attribute, we have, here we have a 4, just we have a 1 common value in the common attribute. So we consider this will be the output of R join natural join S. But outer join as a full outer join mean that we said, okay, here we consider 3, 4, but we lost 1, 2 in R part. So we are going to add 1, 2 and put a null value as a value from C. And then we go to S, we said, okay, we consider 4, 5, but we lost 6, 7. So we put 6, 7, and we consider a null value here from this. In this case, we don't lose any data from both cases. But sometimes we name it left outer join, that we should consider only the left part not to lose anything. Again, first we apply a natural join. And then we said, okay, now we have 1, 2, we lost it. So we mentioned and put it with a null value. But we don't consider right because it is left outer join. Right outer join, we consider the right, we don't consider the left one. So we have here 4, 5 is being already mentioned here, but we lost 6, 7. So we mentioned again with a null value, but we don't consider the left one because it is an R or a right, left, or outer join. So outer joint is a more very special. We rarely use it, but it's good to know about it. This is all for operation, but there are very special case. Even though some references doesn't mention it, but I think you should be aware about it, which is self-join. It is like join, like natural join can be a self-join, or a SETA join can be a self-join. But it will be good that you know about this. Self-join means that in some cases, we need to make a joining with the relation itself to get a special data. Let's return back to this, where we have sales table, where we have a grocery, drink, and price. And okay, we will say, let's take this query. Using cell, grocery store, drink, and price. So you have this query. Forget about the strategy. We will discuss the strategy later. So we have the query said, find the grocery store that sells 2 different drinks at the same price. So if I have to think about it as a SETA join, there is a condition. Normally, if I told you, please give me the grocery store that sells this drink for a price, that sell Coke Zero for a price greater than $2, 3, 4. I can say, okay, SETA join sells drink equal Coke, and I will say price greater than 2. But this is not the case. The case finds that 2 different drinks at the same price. It is a very special condition where the condition, it is not a direct condition based on the value on the, where we can create our own condition. Here's this word. It's more like a comparison between the values themselves. So I have to compare the prices to see where the same price, but at the same time, not the same drink. So I'm making an internal comparison. So the best case, since I'm making a comparison, is to create a copy from the table itself. And then I can make something like a natural join between of them and can build a selection condition. This is, we name it self-join. That I'm joining the table is with itself because I need to build a condition where I have to compare the data between each other. Again, this is a very, very special scenario, but maybe you need it, so you should be aware about it, that you can create a self-join. Later, maybe when you create SQL query, you need it. So the strategy, as I said, by defining another copy of a cell, and I can renaming by name it as, and since I'm going to make two different drink, I just rename also drink, and I keep the price as the same because now I have to make a joining based according to natural join. What is a natural join? Combine the data using the same values in the common attribute, which is the same price in this case, and the grocery store, which is the same grocery store that sell the same price for two different drinks. So I will rename, make a copy, rename the table. I will rename drink to making a drinking one. When I make a joining, in this case, I will consider the price and the grocery store to make a joining for both of them. And then I can build another query after the joining. So I build another operation by making a selection drink does not equal drink one. So in having this copy, now I can apply natural join and apply selection to get what I'm searching for. So whenever there is a comparing for the data in the same table, it would be a good idea to consider self-join. So as I said, I will make a renaming for the table cell to have name it S. I rename drink to make it drink one. So I have now two common attributes cell between cell. So I have this as a cell, and I have now S. Here I have a grocery store price as a common attribute, and to have two different attribute drink and drink one. As an output for a natural join, I will get this. So this is give me the grocery store that has a natural join. So now I can apply a selection for the output, which drink does not equal drink one. I get here, and then I said, okay, the grocery store in this case is Sam, based on what we got it here from this natural join. So it is the same. I apply natural join, I apply selection, but I apply to a copy of the table. I make a renaming for it. I make a renaming for one of the attribute, just to apply the natural join in the correct way. I know how to apply it and make this the whole process. So again, self-join, it is the same like natural join as far as we know it. However, we apply it whenever we need to make. We are not going to, we can't make a classical selection where to build a condition directly. We need to make a comparison in the same data for this relation. This is the whole for today. We will have our lab exercise now. Please, can you take a screenshot of the lab exercise? Because I think so it is not from part what you have. I ask you kindly, all of you now, to get a screenshot. Please get a screenshot that later you will use it. So I think so you have this. I didn't mention the primary key here, but I think so all of you have it this. I think so in the midterm, I'm not sure about it. But this is now, you should write, this is a real application, how you write a relational query, algebraic query, to output the emails, as you said, to output the name of who downloaded Facebook. And the next lecture, you should prepare exam on MySQL, because the next lecture, we will start write SQL query, not relational query. Now relational query, I can understand. You have to make projection, selection, group by, joining. Now the next step, how can I write the code? But now you should aware about the operations. And today we will make more practice about how to use different operations to build the query. And the next lecture will be in SQL. I think so we need 2 more lectures to make SQL and practice, and we will done about what is needed in the course. Later, maybe if we have more time, we'll make a demo. But I'm thinking so we just need 2 more lectures to apply the relational algebra to SQL. Any question before we break you to our rules to do this exercise, and like always, we return back to discuss the solution. More questions? Kura, go ahead.
Regarding to the previous slides before the lab exercise,
You mean
I
this?
just confused with this one, the drink.
Okay.
So we will drink one would be a variable, or we will create another field for
No.
to copy.
You see this? We didn't create any field. We make a copy from the same table. However, when we make a copy, we just change the name of the attribute. You remember the renaming attributes that we discussed, renaming operation that we discussed the last time? Why you make a renaming? Because natural join here, natural join will consider the common value. Sorry, natural join will consider the common value in the common attribute. So the query was to find the grocery store that sell a product with the same product with 2 different price, two different drink with the same price. So I'm searching for the same grocery store, either it would be Sam or Bird here, who's going to sell 2 different products with the same price. So I have to make a joining by considering I need to have same price, same grocery. So this is why I keep them as the same as they are. I just change the name of the drink. Because if I didn't change the name in the natural join, it consider the common value. However, I have to consider the common value for the price and the grocery, but I will consider later to make a selection with different drink. Is it more clear, Cora, this?
Yeah, thank you.
And if you have a concrete question, I'm happy to answer your question. Okay, so we will go now to the rooms, and I will be with you there. I should delete the old room, creating a new one. Move all existing room. And then I make a breaking rooms, create rooms automatically. Oh. Still is closing. So guys, I think so all of us are here, or still there are all are closed. So do you think that we have any anyone want to share his or her solution on any group before I share mine? Go ahead, Josh.
Can you hear me?
Yeah, we can hear you.
Okay, awesome. So first thing I did was we went and kind of started with having a plan of what we were going to do. So for one, we wanted to get the app name from apps and get the related user emails from downloads. So to do that, we used a projection where we're going to project our user emails because that's what we want our output to be. And we did a selection on the app name Facebook. So we just wanted to get Facebook. So to find out who downloaded Facebook. And then we did that
Okay.
on the set join or bag join, I guess, or whatever we want to call it, of
sorry,
apps and
Josh, yeah.
downloads.
Let me interrupt you here. This is a correct solution. Just let's discuss more about how we are going to think. What is the strategy to solve this? So the question say what is the email of the user who downloaded Facebook. So the first point that I always have to think about it, what are the table or tables that I have to deal with? All the data I need, is it in one table or more than one table? If it is in more than one table, how I'm going to join them? So we talk about the email of the users who downloaded Facebook. So Facebook is the app name and the email of the user is user email. So in the table apps, we have the app name and we have two other options to consider, either users or download, because both of them, they have the user email. And since the download, it has a common with the app, so it's better not to go to the cross or Cartesian. It's better to use natural join. So I have to join app and download, and then now I have to consider what more condition I have to build and the projection. Just this is the strategy how to think in such kind of a question. Sorry, Josh, you can continue.
It's all good. For number 2, we were asked to output the names of the people who downloaded Facebook. So same idea, but this time we want to get a result from our users, right? So we found that we had a connection between app ID on downloads and apps, but there is no direct connection between apps and users. So to do that, then we can hop from apps to downloads and then to users, because user email will be connected and then app ID will be connected here. So that's what we did. We went and output the full name of the user from a selection of app name Facebook of the natural join of apps, downloads, and users. Is there anything you wanted to add?
No, I'm okay.
Okay. For number 3, we were asked to output the app IDs, the names and ratings of those applications who have a rating of 3 and above. So we thought, hey, we need to get a list of apps with a rating greater or equal to 3. So we can just project the requirements straight from this table because we don't need any sort of data from anywhere else. So that's what we did. We just projected app ID, app name, rating with a selection on rating has to be greater or equal to 3 from the apps table. One possible alternate answer to this, we weren't sure if this was doable, but we tried to use an extended projection where we did app ID, app name, and then rating greater or equal to 3. Would this work?
Yeah, It can be worked since it's an extended, as you said, yeah. But wait, an extended whenever we are going to make an operation, so like the division, multiplication, difference. But if you are going to apply a condition, we should use a selection. This will not work.
Okay, that's what we were wondering. So we weren't sure
Yeah.
exactly what we could do. Okay, so that sounds good.
So
Awesome.
the first option is the correct one in this case.
Sounds good. Let's keep going then. So then for number 4, we were asked to find the name of the developer who developed Snapchat. So we thought, hey, we're going to be using a similar idea as to what we did for question 1 and 2. So from apps, we need to find Snapchat in the app name. Then using the developer ID, we can get the developer name from developer. So we know that these are connected via the developer ID, right? So we're going to connect the 2 tables using a natural join. So again, we just did a projection on developer name from a selection of app name equals Snapchat from the natural join of apps and developers. For number 5, we were asked to list the app categories and the number of apps in each category. So we're going to be doing this similarly to what we did earlier, where we counted the number of drinks, I believe, something like that. So we're projecting the category from apps and counting the app IDs associated with each category. So we're doing a grouping on category. So we're grouping up all our categories. Now we've got a whole list of things. And now we're just going to count the app IDs so that each category has a number of apps. And we've renamed that table to be just, or that attribute to be number of apps, just to make it clear. And that is done on the apps table. That's it.
Yeah, thank you so much. So you make a group by and then make a count, number of count, yes. Guys, any question for this? I will upload the lecture with the solution for all exercises we discussed and the lab exercise today. Starting next week, we will start working with a DML query, how we can build our query based on the relational algebra, but we start to write a code. And as we did with the DDL, but this time with the DML one. Any questions so far about this, about today? So, like always, if you don't have any more question, I need thumbs up to leave, or I will stay.
Can I ask a question
Yeah, sure. Who's this?
about the group project? It's Elijah.
Yeah. If you want, after the other will leave, we can discuss. Yeah, you can stay. I'll stop
Okay, sure.
recording. So, yeah, people.